This tutorial will help you to complete the questions on homework 22. The first section asks us to graph a system of equations. We're going to start first with y equals 1/3 x plus 3. Remember, this is the y-intercept, so this is a point on the y-axis. We can use this as one of our points on the line and then use the rate of change, right, the slope here, to find more points along that line, right? So the y-intercept is where we're going to begin our graphing, and then we're going to follow a rise of 1 and a run of 3. Rise up, right? Rise is the change in the y-axis, so we're going to go up on the y-axis, and the run is the change along the x-axis. So we're going to go up 1 on the y-axis and positive 3 on the x-axis. Up 1 on the y-axis and positive 3 on the x-axis. Don't forget you can also reverse both of these signs. Down 1 on the y-axis and negative 3 on the x-axis. Down 1 on the y-axis and negative 3 on the x-axis. And that's going to give us our first linear graph. So I'm going to label this graph with the equation over here, which is 1/3 x plus 3. Next, I'm going to graph the second line in blue, starting at my y-intercept. And if your slope, or rate of change, is a whole number, place a 1 underneath. So I'm going to rise 2 along the y-axis and run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And I see my overlapping point. That is the solution to my system. I'm going to label the blue line down here. And now I'm going to name that intersection point. So that intersection point is here, and it is the coordinate pair of 3, 4. Second section. Which relation below represents a function of x? So don't forget, we're looking for no repeating x's, so no repeating x values with different y values. So we don't look at the y values at all. We don't look at those numbers at all. We look only at the x values. So I have a 1, a 2, and a 3. I have no repeating x values, so this is a function. In my second example, I have a repeating value of 1 here and additionally there. That is not a function. Letter C, I have a 5, a 3, and again another 5. These two are repeats, so that is not a function. Question number 3. Which graph below does not represent a function of x? So a function of x, when shown as a graph, which is different than question number 2, when I have a graph, I'm looking to use something called the vertical line test. So I drew a vertical line here on the right-hand side of the screen. I'm going to make it a little bit larger so that you can really see it. Okay, there we go. Now this vertical line is kind of like your pencil, and you're going to drag it across the graph from left to right and see if you touch the graph more than one place at a time. So see how I'm scanning from left to right? And I'm looking to see if I have any places where I touch my graph 2 places or more at the same time. Like I touch the graph here and I touch the graph here. So these are 2 places at the same time, right? It's very obvious. It won't be something you have to really look for. It will always be obvious. So because that happens, we say that this graph fails the vertical line test. And if you fail the vertical line test, you are not a function. So the answer for us is letter C. Question number 4. Evaluate the scientific notation product of 2.7 times 10 to the 8th times 9.4 times 10 to the 3rd. So you're going to pick up your calculator and you're going to multiply these coefficients here, and then you're going to add these powers of 10. So 2.7 times 9.4 is 25.38. Since it's scientific notation, I need a times sign and I need a base of 10. My new power when I'm adding here will be 11. Now sometimes we can stop and the problem would be finished. But for us, our coefficient, which is that leading number right here, is too high, right? You need to be a number that is either equal to or greater than 1, but also less than 10. And 25 is higher than that. So what we're going to do is we're going to modify this number but not change its value. And by modify, I mean I'm going to move this decimal point one place lower so that it's 2.538, and therefore I have to move this power one place higher. And since I am minusing a place value and adding a place value, that actually does nothing to the number. So my new coefficient is 2, decimal point, 538. And my new power of 10 will be 12. And that is the final answer. Question number 5 asks you to solve some single variable equations. So let's see. I'm going to distribute here 8x minus 6, and then my minus 8 gets rewritten along with the right side of my problem. Looks like on my left side I have some like terms here. So I'm going to get 8x minus 14. And then I see that both my left side and right side have x values. But when you're on different sides, you cannot combine. You have to use an addition or subtraction property of equality like I'm showing here. So 6x minus 14 is equal to 4. Again, I have constants on both sides, but when they're on different sides, you cannot combine them, so I'm going to use a property of equality here to remove it from one side and have it appear on the other side. So 6x is equal to 18. Do our final division property of equality here, and we get our final answer. X is equal to 3. Pause the video if you need to go back and try these steps on your own. Question number 6 also requires some distributing. Negative 12 minus 4c, and then I just copy the rest of these terms. Again, my left side has some like terms here, the variable term this time. So negative 12 plus 2c is equal to 24. Now my left side and my right side both have constants, so I'm going to use my addition property of equality here. 2c is equal to 36. Divide both sides by 2, and I get my final answer. Number 7 does not have any distributing, but it does have variable terms on both sides. So I'm going to add 5a to the left and the right side, and that gives me a 6a plus 5 equals 5. I'm going to subtract my constant from both sides, and that's going to give me a 6a equals 0, and that can happen, and that's okay, but that doesn't mean there's no solution, right? No solution is when the variable disappears, and I still have a variable here. So I'm going to divide both sides by 6, and I get my final answer, which is actually the digit 0. So that is the one solution, and the solution is the number 0. Take a look at these last two. Typically, in 8th grade, when you distribute a rational number, the result usually comes out to be a nice integer. So 1/3 of 6 is 1 times 6, and then that product divided by 3. 1 times 6 is 6, 6 divided by 3 is 2. 1 times 15 is 15, 15 divided by 3 is 5. And then I rewrite the rest of this problem, combining like terms if I have them. And then choosing which term to use a property of equality on. Well, my solution is a constant, so I'm going to subtract 5 from both sides. That leaves me with negative 4c equals 32. Divide both sides by negative 4. And my final answer is negative 8. Final question. This 6a is not being distributed, but the 8 is. And now I can't add 6a plus 8, right? And now I'm going to combine like terms. 14a plus 8 equals negative 2. Subtraction property of equality. And then division property of equality. And this one does not come out to be an integer, right? Negative 12/14 is actually my final answer, but I'm going to reduce it to, let's see, I think these can both be divided by 2, and that's it. 6/7. Let me double check here. Did I make any mistakes? 8a plus 8 minus 2. Nope, that looks good. So pause the video if you need to go back, or slow it down so that you can check some of your answers. Oh, I see. I did make a mistake. Do you see it? I found it. Where did I get that 10 from? That's crazy. I don't even know how that happened. Let's go back and fix that. I thought it looked weird. Subtract 8, and that's where I got the 10 was the answer, but I must have been working too fast and I put my answer up here by accident. Divided by 14. Okay, so the answer is actually negative 5/7, not 6/7. Hopefully you saw that mistake. All right, last section. Simplify each expression and write using positive exponents. So here I'm going to get negative 3 plus 9, so that gives me r to the 6th power. Here I'm going to subtract my power, so that gives me 5 to the 8th. And here there's no math to do, but I can't have negative powers, so I need to take the reciprocal. And then this one's tricky. Sometimes kids forget about having 2 minuses in a row, right? 3, subtract negative 5. All right, Juan wrote that a squared times a to the 6th is a to the 12th. Correct his mistake. Well, a squared times a to the 6th is actually a to the 8th. Then state in words how you were able to find your answers. Let's see. When multiplying like bases, keep the base the same, and add the exponents. That's how I was able to find my answer. All right, last question. Which equation does not represent a linear function? So anything that can be written in the form y equals mx plus b is a linear function. And look at that letter x and look at that letter y. They have no powers, right? They have no powers, and they have no variables in the denominator. So that's really what we're looking for here. So this one is okay. And even though this one has a power, it's okay because x and y don't have powers. This is an mx plus b form. This is the one that breaks the rule because x has a power of 2. All right, that concludes our video for homework 22.